Greetings, everybody. Thank you for being here. My name is Travis Grant. I'm a project coordinator at Project Auravana. Project Auravana, we develop a set of socio-technical standards for an alternative configuration of society, a configuration of society that's different than our current configuration, a configuration of society that we might call community or a community type configuration of society. We produce socio-technical standards that visualize, describe, explain this new configuration of society and also the present configuration of society. So we have been able to accomplish this by means of conceptual visualization. Or concept mapping, concept modeling, basically diagramming spatially our concepts and objects in an integrated and unified manner. We've been able to come to a fundamental understanding of the configuration of every type of society, and by having that kind of systems engineering modeling approach, we can then intentionally configure new types of societies. Maybe old in some ways, or maybe truly new. A community type configuration of society, again. So what I'm saying is by visualizing our concepts and also objects, we can come to a greater understanding of the present operation of the real world and potential future better operations of the real world. And the best way to come to this new sort of integrated understanding is through concept modeling. This is the only slide with text or significant text on it. And of course, it would be a slide with text because concepts are defined and objects are pointed to. It can also be modeled spatially, or concepts in relationship to other concepts and objects can be modeled spatially, both 2D and 3D. But the idea of a concept model is essentially a spatial organization and representation, because it's a model, so it's representing something, of knowledge or ideas. So this slide brings together the idea that we can more greatly understand concepts and objects. We can model multiple concepts and multiple objects themselves and multiple concepts themselves. And we can do that in what we call a concept model. So a spatial organization and representation of knowledge or ideas that enables a visual understanding of relationships and boundaries between different concepts. So this is a visual process, a visualization process, and an actual visual deliverable at the end of the process. Through visualization and pattern recognition, concept models clarify conceptual operations, the concepts themselves, the subconcepts, objects, object relationships, so that therein they facilitate shared understanding because it's visualized, and when it's visualized, it's more easily shared and understood. And they enable complex societal operations. So later in this presentation, we'll see how concept modelism is a fundamental aspect of the socio-technical system we see around us. Then as well, any operation that can be managed and any object assembly that can be built can be visualized conceptually. So the arrangement of objects and their hierarchy can be visualized, and the arrangement or steps of the processes that take place to those objects. You can also arrange the concepts related to how service operations are useful. Those can also be arranged. So a concept model, of course, is a very generalized term that can be applied to many different disciplines and is applied to many different disciplines, and therefore it has multiple other AKAs, or also known as, and some of these include concept map, concept diagram, mental model, mental schema, mind mapping, visual databasing, visual data structure, knowledge map, knowledge graph, concept graph. And so what we see here on on the right-hand side of the slide, getting away from most of the text for the remainder of this presentation, up at the top we see the structure of the map, or how we're mapping this structure. On the left-hand side we have shapes. We essentially have geometric patterns. And so here we have, in fact, three. We have one circle up at the top, and then we have two sort of ovoids, sound like circles but not full circles down below, and then we have two rectangles that attach to elongated rectangles, often called lines or edges, or sometimes even itineraries, that connect these three enclosed areas. And on the right we have the shape on the left, and on the right we have the count, and we have three count patterns, or three number lines. We have one, starting 1, that's one number line, and then 2A, 2B, that's a separate number line, and then A1, A2, that's a third number line. And so we can begin creating multiple additional number lines, thus making the counted structure of our database, or of our graph, knowledge graph. So then we can overlay the count patterns on the geometric shapes, and we come up with a more clear visual understanding. And then, of course, that visual understanding can be applied in the real world and has meaning. So here we have one applied example. We have the water sector for a habitat, and the water sector has two production techniques, and those two different production techniques produce two different types of end water products, salt water and potable water. So that's just one application of this. So what are we doing here when we're talking about concept modeling and the visualization of concepts? We're essentially saying we can begin thinking and working together through a similar common information system, and thus cooperate and create a more optimized and fulfilling life for all of us. We can integrate information and have enough of an awareness of the total information set that we can see the fundamental patterns of that information set, that societal, socio-technical information set, and we can come up with better, common, together solutions. And so here you see the different agents in the total populated system here in this concept model. And so each of these individuals has a similar real world, you could say, information model in their mind at the same time. That doesn't mean they'll all be the same, because of course in community is one of the first and only systems that accounts for both the individual and the social together. You have a set of individuals here, and then you have a socially common information system that facilitates a diverse but also optimal way of living for the individuals. So the social and in the individual accounted for globally and also locally. Unlike the current system, where there's competition between individuals, there's a lot of obfuscation, so they don't have the entire model in mind, and then there's also private property. What are we trying to do in many respects? We're trying to transition people and resources from one configuration of society to another configuration of society. And we say that we can model out all of that. We can model out the configuration of society we want to transition from, we can model out the transition, and we can model out the transition where we're going to. And we can do that intentionally now because we have an integrated understanding of the fundamental systems that make up, any configuration of society. So one of the other terms for conceptual modeling sometimes is like concept engineering. So we can begin engineering a new and better configuration of society because we understand the fundamental systems that society is composed of. So the information represented in this concept model, this shape model with the circle within the circle, and then the four sectors of the circle there, that's a significant model in terms of the whole community standard that represents one perspective, one view on the real world community information system model. This is another view of that model. So that model is composed of standards, and these standards are developed by working groups, and the working groups develop in a textual version of these standards, they develop articles, and then in the software version of these standards, for example, the decision system has decision service software, and those are software, that's software development, but they're developing software standards, software interfaces, and they are part of this as well. So this extends out beyond just the textual articles. There's also the concept models, of which the Auravana project now has, I think, over 3,000. And so the concept models, the figures, the images, the 2D and 3D images that represent the information in this standard are the figures or the concept models. And those also fit in each of these standards and are file named, title named according to their position in the standard. So we're visualizing through standards and integration of information, the operation of a different configuration of society, a configuration of society where there's no trade, no market, no state coercion, and no socioeconomic class division. And we can do that by understanding the fundamental systems that compose every configuration of society and then subconfiguring those standards so that they represent a community type configuration of society. So the four fundamental standards of any configuration of society are a social system, decision system, materialist system, and lifestyle system. Of course, in modern society, most people refer to society as only having two systems, a socio-economic system, so a social system and an economic system. But an economic system is decisions about the acquisition, allocation, transformation of resources into needed goods and services. So it's actually decisions. So at a higher level, an economic system is a decision system, decisions about resources configured into basically productive habitats. And so the economic system is a higher level decision, and the social system is correct, but then they also forget the material system, the physical real world around us, the material aspect of the whole system. And then they choose not to, in many respects, account for the lifestyle system, which is another separate system. Some people, so if you have the social, decision, material, lifestyle, some people refer to this as kind of like the culture system, like what's the culture, what's the life experience, what's the lifestyle. And of course, that's actually common to almost all configurations of society also. So the lifestyle, like you can actually separate the lifestyle into a series of life phases. And of course that would be like nurturing, weaning and infancy, then that would be education, then that would be contribution in community or employment in the market state, then like a leisure or retirement phase of life. Of course, you can always continue contributing. But anyway, those are the four common sort of life phases. So we can begin thinking about how we could configure society better. Of course, every configuration of society also has a project plan, project execution, and a document that could basically or does provide an overview of that configuration of society. So in the market state, there are thousands, maybe millions of project plans and executed projects for human habitation, human economic, socioeconomic fulfillment at the social scale. In community, it's more simplified, and there's also a little bit more complexity in some ways. In community, you have an integrated system. Information feeds from that social system where we have a direction orientation approach into a decision system in which there are local and global decisions, which is described by a decision system within which an operational decision service system operates to resolve decisions at the local and global level. That feeds in, both those local and global decisions feed into the material system where people live in a network of habitats that share access to common heritage resources, and where their real world material material needs are fulfilled, and then that creates their lifestyle over the different phases of their life. So this can be modeled, you see, in this way. It can also be modeled in this way, and here we see the different standards of a community type configuration of society. So this is where, so here we have the two axiomatic categories or concepts at the highest level for any configuration of society and for the real world in general. We have objects, the red, and blue representing concepts, and so at the bottom we have a network of these material city systems. Again, a habitat is just an AKA for a city or settlement or village or town. We don't want to use any of those terms because those are all specific, so we use a more technical term called a habitat. At the global level, habitat service system, global habitat service system. So a network of those on planet Earth, which is our biosphere, and then we have the shape of our physical bodies, and then that central blue star in the center is our consciousness, in which we conceptualize, sometimes known as abstract. We have these mental models in which we have understanding, awareness, we have access to data, knowledge, values, we take decisions, and we can share goals and priorities. And so this all interconnects at that rope model in the center, where you have the physical creating the border, the enclosure, and then you have the consciousness star in the center, where each individual consciousness conceptualizes, and we can begin conceptualizing a better configuration of society together. And so here's another definition, the only other slide with real text. Concept model, it's basically a visual conceptual data structure. The two models below are two different ways in which you can represent the community type real world information systems model. And so on the left hand side we have the that circle kind of with the earth you see there. That represents the material system, the physical system, where there's a network of physical habitats and physical people exist, and then under that is the root conceptual operation structure and knowledge structure that forms our living life experience in a physical material habitat. On the other side, this whole model is more of an information model. But of course the material system is represented by below. That's only showing 3 of the systems or standards or information sets. Again, you can have many different views on this information. Same information, just viewed from different perspectives. Maybe some of the perspectives will show more. This perspective shows a little bit less. And then we have the concepts that are derived from those primary 3 concepts extending out. Could also be objects. Down below, the material one would be potentially an assembly of objects forming technologies, and those technologies forming a larger production technology known as a habitat. So you can represent concepts in modeling form in both 2D and 3D modeling form. So the prior models that you've seen, concept models, have been 2D, but you can also represent the information in 3D. This isn't a 3D view itself, but this is in 3D. This is in Unreal Engine, and so we're showing the models. So in the center you have an axiomatic concept at the top, and then you have meaningfully separated conceptions, subconceptions of that top level axiomatic concept. Over on the bottom left, you see that kind of, like, I don't know, clam egg-shaped thing. That is the real world model in 3D shown from the side, and that's interconnecting with the economic calculation, and those are some of the economic calculation variables. And then on the right hand side we have object assembly models. So if you have in your mind an idea of each of these as an object, you can point to every single object. Remember, objects are pointed to and concepts are described in a dictionary, and so concepts described, but each of them can also be modeled visually, and objects are pointed to in a Pictionary. They might also be a textual description, but in order to fully understand it visually, it's pointed to. Whereas a concept is not an object. You can't point to a concept. What you're pointing to there is a separate shape that's associated with a concept in terms of that 3D concept model. So if I was to point to that concept model, I'm actually pointing to what looks like a block. and that block has an associated representation, maybe like 1A, and then that has a specific meaning separate. So when I'm pointing, certainly I guess you could say commonly I'm pointing to the information, but technically you're not pointing to the information. Technically you're pointing to a block. But sometimes we speak that way in order to make things more clear. You point to objects, you define concepts, and concepts can be associated with shapes in both a 2D and 3D form to help convey meaning to other individuals. So concept models, as I said, form the backbone of our socio-technical society. And so there are some disciplines in the world that learn about concept modeling early, and there are some that don't. I think it's becoming more common throughout the disciplines. Certainly in engineering and architecture, certainly data communications, you learn about concept modeling and the importance of concept modeling, how conceptual models actually create the socio-technical structure we have around us. And here is the backbone of the internet, the fundamental concept model that makes up data and communications, a form of data and communications across the internet. So you have the TCP/IP model, and then you have the OSI model. I learned about this years ago. It was kind of like a mind blown when I did that. We can begin associating information with shapes and to help us understand and also to help us build and engineer things, especially more complex things. So this model essentially describes the a large part of the internet and how data and communications occur through the internet. And you can look into each one of these concepts and then the operational processes they're in, and some of them actually relate only to information, and some of them relate to computation, and then some of them relate to the physical aspects of the material world around us, like modems and like the electrical cable, and adapter devices. So it's like an interconnection model, and so it allows for complexity and allows for great understanding. So if we could all learn to concept model, or at least understand what concept models would help us greatly. It can take a little while. I remember when I was learning about concept modeling, it took a little while to actually understand what a concept model was and how it was a useful tool for visualization. And once you could understand concept modeling, once you create a few concept models, then engineering new things and understanding previous engineering becomes more easy. It allows for greater analysis. So what I'm saying is that we can begin thinking about engineering and modeling, visualizing together a different configuration of society using the fundamental systems that every real-world society really is composed, and we can subcompose those into a community type configuration. So here's the real world community model, and so you have social system, direction, orientation, and approach, a decision system where working groups resolve decisions, whereas at the social level, working groups develop standards, and then at the material level, you have habitat service teams that produce and operate habitat services, and then the lifestyle is the people accessing the total societal system, including the information system and the material system. And so this is a high-level model. Here's another representation of the model, the direction, orientation, and approach of the social system. This includes the biosphere and the material system. So all the common heritage resources available to us. And this also has repositioned the lifestyle system. Instead of being a sector on the left, it's just put it in the bottom sector. So there are only 3 sectors, and then the bottom sector is subdivided into material system and lifestyle system. You can also represent the information this way. So again, concept models, you can create concept models and make them more tabular, or you can make them more visual like this, more like flow models where you can actually see the flow of information, the flow of objects. Again, information doesn't actually flow because it's not an object that you can point to, but it can still be represented, like we can represent, we can model and represent things, and that can help us in understanding that aren't necessarily physical. By attaching them to shapes, that can help us more greatly understand. And certainly we can then begin applying those counts and begin computing. So this concept model shows a transition from the market state project to a community transition project, because we always have that idea of community in mind during transition. We're not leaving it open what we're transitioning to. We're developing the next iteration of what we're transitioning to, and we're transitioning to that, and then the next, because the standards for community are living. Like really all society is an experimentation, so the standards kind of in that sense are too. So here you can see from the left hand side where we have the market state, we have a transition of conditions, resources, and people into a more community type configuration of society. And that configuration of society we can represent also in this real world community information systems model. You can also represent the market state in that circular model too. That's not done in this concept model. So here we have like an organizational chart for the operation of a community type configuration of society. And so you can see these can be more, there are many different ways you can visualize concept. This is just one way. You can make them more like onions, you can make them more tabular, you can make them more stacked based, there are many different ways. And so it's just coming to an understanding of what the shapes mean. Often shapes mean the same thing. Sometimes concept models have keys that describe what some of the shapes mean. So remember, everything is here is still a shape. Those things that you see as lines, that's an elongated rectangle. You just basically have a bunch of like shapes, and those elongated rectangular lines are just a unique form of shape, often either just representing association or representing some sort of flow. There may be arrows, there may not. A lot of these, sometimes they're more clear, sometimes they're not. In the future, I would expect that an AI would be able to like help people understand them, or you just take your time and kind of look through it in order to understand it, but just like you would have to do that with any concept model. So these are conceptual relationships, and you can also take all these conceptual relationships and type out a textual description. So again, what we're modeling the textual descriptions and the object assembly descriptions in the standards. These are just, this is just a concept model of things that are described in text. So up at the top here, we have the network of integrated cities, and then we have a single city, and then we have project execution. So the city is essentially executed as a project. Also on the right-hand side, every city is a master plan. So cities are master planned by local master planning teams, and the entire society is operated and coordinated as a global contribution service. So you have both kind of operating together in these customized habitats. Project plans, charter overview, education curriculum below, that all has kind of to do with the operation of a societal system and the education of other people into that societal system. On the right hand side, you see the primary functions of the organization kind of as a whole, in particular during transition. You have contribution as a service, you have transition as a service, that's transition of people, resources, information, and you have residentation. You have the agreements that people agree to in terms of living in a single individual local habitat or regional habitat network, and you'll have the total set of agreements, the set of agreements that they've agreed to, and then you actually have like the moving into these locations as part of the residentation program. And then you have an education service to educate people on the societal standard itself and the potentials for contribution to this society. So directly underneath, you see those functional services laid out. And to the left-hand side, underneath where we're talking about the total projects available, the overview charter, that's like the overview standard, and the education curriculum, which like is essentially the whole standard. They are all essentially related to the whole standard because they're informed from the standard. And then under that, you have the social, decisional, material, lifestyle standards. Those are coordinated by a coordination team, and then underneath that coordination team, you have coordinated working groups that develop individual aspects of that standard. If you go up from the right-hand side, from contribution, where you have those functions, contribution, education, transition, representation, you see users, people on planet Earth are moving into community access and acquiring personal access, common access, and contribution access throughout all phases of their life, a step up. And what type of access are they acquiring? They're acquiring need fulfillment. The next step up within this habitat network over to the left, material need fulfillment for life support, technology support, and exploratory support, in which there are some unique systems like the production system that produces, and then the user systems of life, technology, and exploratory, of which there are the final demand users, and then there are the intermediary productive users that also are represented there. And then so we have people contributing to the continued operation of habitat services for local, personal, and common access. So you can see how a concept model like this can convey a lot of information or a little information. They can be simple or complex, often simplex, because you can begin bringing in the whole discipline. Because what are we dealing with here? If we're looking at this, we're dealing with a new type of information system, like a societal sciences based information system, kind of like a new discipline of sorts. So here we live in different materially configured environment. This is just a hypothetical image of a circular city in a community type configuration of society. Not all cities in a community type configuration, not all habitats will be of this circular layout. You can imagine multiple other different layouts, and especially updating existing urban environments, which can be done too. They won't look like this. This is just an inspirational piece. And using this sort, new cities will be created on the planet, and some people might want to change their cities over to this city. Using this sort of prototype, we can begin running economic calculations and begin operationalizing in a simulated manner this sort of system over a number of years, so that we can begin slowly transitioning people, resources, physical resources, and information using the market, state, and public, and also education to facilitate a safe transition to a new configuration of society. So you can see we can model again in multiple different ways. This is another way of modeling the primary real-world community information systems model. And here you see in the center, those are books or standards. Of course, the standards are not only textual, they're also visual, 2D images, drawings, simulation, software. All of that relates to the standard. Then you have the operational standard, and you have decision service operations software, you have material habitat service operations software, and you have the software for the standard setting teams, the social system software itself, and also the design, the collaborative design of new technologies and new configurations, which fits between social and decision. And then the operational software for operating production systems and operating material services and habitats, and that's operating software. And then of course you have the user interface software over on the left-hand side, where there's actually 3 layers. There's the residency user interface, then there's the personal access, and then again the scheduled common access. So this is one way of representing that information. And you have different services throughout. You have like information services, education services, design engineering, design preference solution services. You have a variety of different services to help both the user stakeholders, the global population, and the contributors make together create a solution and take optimal solutions for everyone. And you can do that at the local and global scale by modeling all this information out. So this is just a small network in the local network of low density habitat surfaces. You have the Auravana project habitat on our right, and you have the Aura Curve habitat project on our left. Both are based on restorative agricultural techniques. So the one on the left is mineral based, and those are larger buildings, and then and fit less people, but fit more space for activities. And then on the right, you have more bioconstruction based, which fit more space for people and less space for activities in their dwellings. All of these are just different configurations of dwelling in community. We're saying that you aren't forcing anybody to live in a specific way. We can begin optimizing our systems so people can see what resources we have and what potentials are available, and then making the best solution therefrom to give us the most freedom, to give us the most restorative justice and distributive justice in terms of access, and efficiency in terms of our resources and our time, especially labor time. So on the left, mineral-based, on the right, bioconstruction-based, using primarily these habitats produce food in the form of a restorative agricultural pasture land. There are many other terms for that: restoration agriculture, syntropy agriculture, a lot of other terms, polyphase, a lot of other terms for basically what we'd be using here, a 3D landscape of cultivation of animal and plants in order to produce the required needs for food, fuel, and fiber for not only these habitats, but other habitats in the habitat network. So that would be one of the potential primary productions of these two habitats, if these habitats, I would assume, we're producing. So these are prototype habitats. Again, these are low density. In a community type configuration, we imagine many different configurations of habitat, from high tech to low tech to mineral to primarily mineral, from primarily mineral to primarily bioconstruction, from million population density sizes to the size of small 100 people, maybe less, habitats. So we extend the gamut from from people. We allow for great customization, is what we're saying. Great customization in terms of where people would like to live and with whom they would like to live. So we're given what's available, and I feel that we're creating more customization because we're actually accounting not only for we're accounting for decisioning at two levels: the residency agreement level and the preferential customization of the local habitat level. So you have decisioning at both levels. Both levels involve participators. And then at the local level, you have also participation from local residents who are part of a decision service working group to facilitate the next master operations specification plan for that local configuration of the habitat. And then you have the global decision service system that facilitates decisioning for all local habitats, and also facilitates decisioning for globally relevant aspects of the economic operation, like mining. So you have decisioning at both levels. And the decisioning at the working group global service level is more connected to the standards. They're more seen as part of the standards, whereas although they also facilitate development of the master plans, but more in terms of fixed production. And then the local habitat service decision teams facilitate the local residents' decisioning agreement on the next configuration of the more flexible parts of the master plan lasting 3 to 5 years. Of course, when you're dealing with a global heritage resource set, you also need calculation globally. You'll have, millions of constraints, and these need, and maybe not million, you won't have millions of functions, but you'd have millions of constraints, and these need to be calculated for at the global level. So there's global and local decisioning, allowing for great, I would say, even more freedom in fulfillment of our needs optimally, and more freedom in allowing us opportunities for expressing our preferences. And so this right here just shows a small network. Again, these are in new city form, but of course you could take like a current urban environment, put a slide over it, and go from current urban to, market state, its current market state version to the community type version in the city. And that would be based upon community standards. And that would represent something very different than almost all urban environments, suburban environments, any built environment in the market state. Maybe not all of them, but many of them would look a little different. Some of them significantly different. So that's the end of the presentation, and you can find the standards on our website under /standards, auravana.org/standards, and you can find this presentation with the bottom QR code. Yeah, we think we're finding the way to a community type configuration of society. That's been our inquiry, and that's what we're developing. And we think it's absolutely possible. This, I think, is just the start. If you want to look at some of the concept models that our project has, we have over 3,000 on the website. It's auravana.org/figures. And we basically think that if it's not visualized, it's not understood. Together, we need to understand through visualization. And it's only through visualization that we can have non-conflicting understanding. It's like when they dealt with when engineers and architects were building just in AutoCAD, and you'd have different engineers working on the project in different layers or in different AutoCAD files, and then when they began building the project in 3D in the real world, there'd be conflict between a conduit and a wall, or a wall and something else. And so now what architects do is they work in more like simulation software. They work in 3D software where in 3D you can see when these objects overlap and conflict with one another. And we can begin doing that with our mental schema, our mental models, our concept models, our conceptualizations of what society is and could be. And so I think Auravana is presenting, along with a lot of other organizations around the world, and Auravana is presenting a interdisciplinary approach to modeling society. And I think this is something new that might be on the planet, coming onto the planet. I mean, we've seen the introduction of machine learning intelligence, and now we're seeing, I think, the integration of all these separate disciplines under a unique supra-interdiscipline we might call societal sciences, and we have sufficient access to information to be able to create this new discipline. And this new discipline will allow us to engineer a better, more optimal, more fulfilling and flourishing configuration of society in the near future, whatever that is. When we think about transitioning to this new configuration of society, this might take time. Everything in the real world has a time component. There's also an education component. There's a residentation component. There's first saying, yes, I understand, or yes, I'm even aware, or yes, I'm interested, or yes, I would like to go live, or yes, my neighborhood would like to live, or yes, my nation would like to live, or yes, our union of nations would like to live in a global commonwealth operation. And so we can begin doing that with concept models. We can begin conceptualizing this new operation. So I'm going to put my picture right here, and I think there's a big and better future for all of us on the planet. And I work for this direction because I think it's possible, and I think we now have a visual concept of operation, of something that represents a workable, feasible, livable community type model where there is no trade, where there is no state coercion. That's going to take some time to transition from. And there is no they're all going to take time to transition from, and the public, the people, feel are knowledgeable about how society works, and are facilitating a better society, because a certain population of the people at any given time are in the contribution and employment phase of their life, doing work, recreating and perpetuating society, and they come from the education phase, and they come from the nurturing phase. And so, people then say, like, where can we begin transitioning? And it's like, well, there are 3 dimensions, and then there are the different phases, and what profession are you in? What influence do you have? How can we begin further improving and testing and experimenting with community standards? And where can we begin having influence in education and facilitating a more real world understanding of the world around us, or a more accurate understanding of the real world around us. And all of this takes time, because changing one's mental schema and changing the material environment obviously takes time. The amount of time taken actually is shortening in some respects, because we're entering a more thought responsive environment. Technology is allowing the environment to respond to us more rapidly, either without our knowing or with our knowing. And so in some respects, I see a lot of people feel a lot of urgency around this, and I think that's good, and I think we should work on it as if there's urgency, to the extent that each of us individually is able to. But this is just realize, I think this is going to take a while for us to transition well and safely. I mean, even having currently developing this, I mean, I would not say it's like, people say, is it practical? Let's make it practical. When can we make it practical? And again, then you'll ask, what's the education level of the people? How many people want to become residents, education, residentation? What's the state of the development of the standards as texts themselves? What's the state of the development of the software system? What information and resources are there in community type configuration? What don't we have access to in community? So this, I think, is going to take time, but we build a working group structure, we build a standard setting organization that allows over time the education, the residentation, and then the total transition of people, resources, and information into a community type configuration. I think we're going far. Bye.